Dear students, myself P.P. Sutar, Associate Professor, Department of Chemistry, Gopal Krishna Gokule College, Kolhapur. Students, for this class of B.Sc.III, you have 4 papers at semester 5. Papers are paper number 9 Inorganic Chemistry, paper number 10 Organic Chemistry, paper number 11 Physical Chemistry, and paper number 12 Analytical Industrial Chemistry. Now in the paper number 10 Organic Chemistry, you have to study spectroscopy. Now this topic is new to you, and therefore I will start my lecture with the introduction to spectroscopy. The topic includes these 7 points: the meaning of spectroscopy, the nature of electromagnetic radiation, the parameters like wavelength, frequency, energy, amplitude, wave number, and their relationship, different units of measurement of wavelength and frequency, different regions of electromagnetic radiation, interaction of radiation with matter causing absorption, emission, fluorescence, and scattering, then types of spectroscopy and advantages of spectroscopy methods, energy types and energy levels of atoms and molecules. Now in the meaning of spectroscopy, what is meant by spectroscopy? Spectroscopy is the study and measurement of interaction of radiant energy with the matter. When matter is exposed to the electromagnetic radiation, then there may be reflection, absorption, emission, scattering of light. When the matter is exposed, there may be response, and these responses produced by the interactions are recorded in the form of spectrum. These responses can give the information about electronic structure, molecular formula of the molecule, atomic connectivity, size and shape, relative orientation of the groups, and stereochemistry. Then next point is nature of the electromagnetic radiation. The electromagnetic radiation is radiant energy emitted by a source into surrounding environment. The radiation consists of mutually perpendicular electric and magnetic. These are the, for example, electric and magnetic vectors, and they are perpendicular to each other, also perpendicular to the direction of propagation. As these radiation do not require any medium for transmission, they readily pass through the vacuum. Now radiation has both wave and particle nature. The wave is characterized by interrelated parameters like wavelength, frequency, wave number, amplitude. Let us see one by one. The first one is wavelength, which is denoted by lambda. The wavelength is the distance between two identical points on the successive crest. I am showing what is a wavelength. This is the two identical points on the crest. The wavelength varies largely, and therefore for measure different units are used depending upon the radiation used. The next parameter is frequency. The frequency is denoted by letter nu. The frequency is the number of complete cycles or wavelengths passing through a point per second. I am showing here. This is the one cycle. Thus, cycles, how much cycles are passed. The frequency is measured in terms of cycle per second, CPS, also called hertz, but most commonly megahertz per second is used. The 1 megahertz is equal to 10 raised to 6 cycle per second, which is equal to 10 raised to 6 hertz. Frequency is related to the velocity c and wavelength lambda by the relation nu is equal to c by lambda. As c is a constant, the relation becomes constant by lambda, and therefore frequency is inversely proportional to the lambda. As frequency increases, wavelength decreases, and vice versa. The next parameter is wave number denoted by nu bar. It is the number of cycles or wavelengths per centimeter distance. Its unit is per centimeter. The wave number is related with wavelength by the relation nu bar is equal to 1 by lambda. Next parameter is amplitude denoted by small cap letter A. The amplitude is the maximum displacement of wave from the line of propagation, that is x-axis. Next parameter is velocity. It is the distance traveled by the wave in a unit time. It is commonly expressed in centimeter or meter per second. The velocity of a radiation depends on the medium through which it passes. In the vacuum, its velocity is 3 into 10 raised to 8 meter per second. Velocity is related to the frequency and wavelength as velocity c is equal to frequency into wavelength, that is a c equal to nu into lambda. The next parameter is energy. Electromagnetic wave carries energy in its oscillating electric and magnetic fields. These fields are oscillating perpendicular to each other. But practically, the radiation carries the energy in the form of energy packets or particles called as quanta or photons. Each photon has discrete amount of energy and it is given by Planck's equation E equal to h nu, where h is a Planck constant, and therefore the relation becomes E equal to constant into nu, and that is energy is directly proportional to the frequency. Now E is also related with lambda, and the relation is E equal to hc upon lambda. As h is a constant, c is a constant, and therefore energy is inversely proportional to the lambda, that is, as energy increases, wavelength decreases, and vice versa. Energy is also related with wave number, that is h nu bar into c, that is the final relation is E equal to h into nu bar into c. Students, let us summarize the points studied so far. We have studied the meaning of the spectroscopy, the effect of radiation on the matter. Then we have studied the nature of the electromagnetic radiation. Then we have studied the different parameters like wavelength, wave number, frequency, energy, and their relation in the mathematical form. With this, I conclude my today's lecture. The remaining portion will be studied in the next lecture. Students, go through these points, note down some important points, and start study from the beginning. Thank you.